This question, he has given three phase currents, that is IA, IB, IC. Okay, magnitude and phase angles he has given, and we have to find positive sequence current. If you see the relation between sequence currents and phase, they are related as, we know that in terms of matrix IA0, IA1 and IA2. This is equal to 1 by 3 times of, this is 1 1 1 1 a square 1 a square a, and these are phase currents IA, IB and IC. From this, what is positive sequence current IA1, which is equal to 1 by 3 times of IA plus a times of IB plus a square times of IC. Okay, now substitute these values. IA he has given as 18 at an angle 0. What about A? A is an operator which is equal to 1 at an angle 120, and IB he has given as 10 at an angle minus 30 degrees plus A square is 1 at an angle 240, or you can write it as 1 at an angle minus 120 into IC, that is 10 at an angle 30 degrees. Okay, if you solve this one, you will get positive sequence current IA1 as 6 at an angle 0 degrees amperes. So option A is correct. Get this question. This is very good one. Okay, people get confused how to solve this one. Okay, now he has given a current transformer mounted over 3-phase 3-core cable. Okay, now let us draw a 3-core cable. Okay, now this is a 3-core cable. This is called core, and this one is, you can take it as sheath. Okay, let us take, this is R phase, Y phase and B phase. Okay, you have a 3-core cable and he connected one current transformer between a sheath and armor. Okay, now this is sheath. Let us take it for R phase. This is sheath. Okay, and armor will be on the surface of core. Okay, so this is the two terminals we have. He connected one current transformer CT. Okay, see here, he is measuring current between a core and sheath. That means only a phase. Okay, when this current transformer is connected between these two, this is treated as LG fault, because current transformer is having very less resistance. Okay, you can take it as approximately this is equal to 0 ohm. Okay, current transformer resistance, so it is treated as LG fault. Okay, now what is LG fault current? IF is equal to 3 times of IR naught. So this is option D, 3 times the zero sequence current the current transformer will measure. So option D is correct. Maximum input signal frequency that can be used with a circuit is limited by. Okay, this is based on cathode ray oscilloscope, that is CRO. The maximum input signal frequency that will be used with the circuit is limited by vertical amplifier.
Question is, a unity feedback closed loop system has open loop transfer function g of s equals to 1 by s square and a proportional derivative controller gc of s in the forward path is equals to Tp into 1 plus TdS, where Tp and Td are positive adjustable parameters. Which one of the following statement is false regarding above unity feedback closed loop system? Comes to statement A, the system is always stable. See, in the forward path, we have added a proportional derivative control. Means it adds 0 to the open loop system. Means adding 0 improves the stability of the system. Means statement A is true. Comes to statement B. The system may have damped oscillations for the unit step input. See, if we take the closed loop transfer function, that is closed loop transfer function equals to g of s by 1 plus g of s h of s. H of s equals to 1, g of s equals to tp 1 plus td s divided by s square. If we find out the characteristic equation, that is 1 plus g of s into h of s, we will get a second order equation. Based upon the TB and TD values, there is a possibility of getting a damped oscillations for the unit step input. Hence the statement B is also correct. But comes to statement C, that is the system amplifies the noise. Adding 0 means it, because the proportional derivative controller acts as a high pass filter, so there is a possibility of amplifying the noise too. So statement C is also correct. But comes to statement D, the system has 0 steady state error for unit parabolic input. The steady state error is defined as limit s tends to 0 s into r of s 1 plus g of s into h of s. If we substitute the corresponding values where r of s is the parabolic input, h of s equals to 1, g of s is mentioned in the above equation, then we will get this equation outcome as a finite value. But in the option D, specified as a 0. Hence, option D is the wrong statement regarding above closed loop feedback system. Hence, the option D is correct. Question is, for the given block diagram, we have to find out the transfer function. By Mosson's-Gaines formula, transfer function equals to, for first forward path is G1 into Z2, second forward path is G2. If we remove the forward path, there are no individual loops as well as there are no individual two non-touching loops. Hence, the delta equals to 1. In the second case too, delta equals to 1. 1 minus first non-touching loop is G1, Z2. There are no other loops. Comes to two non-touching loops, there are no two non-touching loops. Hence, the transfer function equals to G2 1 plus G1 divided by 1 minus G1 G2. Hence, option B is correct.